Hey everyone, welcome to week 7 on Algebra 2A Live. We're going to be going over the quadratic formula today. So week 7, we should go into the assignments. You got our textbook, you got our videos here recorded, paper pencil problems. Make sure you're keeping up with the class, getting all this stuff done. Our objectives for the week is what we're going to learn. We're going to learn how to take a quadratic equation and use the method of completing the square to solve it out. Another method of solving quadratic equations. Then we're going to see how the quadratic equation, or the quadratic formula, I need to slash that out here. Quadratic formula is actually derived from the method of completing the square. So talk a little bit about where that comes from. Then finally, we've got all these methods of solving quadratic equations. We're going to talk a little bit about how to determine the best method to solve it. Then we're going to switch gears. So again, this is all about solving quadratics. Then we're going to get into graphing, parabolas, parts of a parabola, and how to use all the algebra we've done and connect it up with a graphical form. All right, you guys ready to get going here? So where are we at so far in this class with quadratic equations? Well, a quadratic equation, if you remember, involves x squared. So we have this whole linear part, bx plus c, but now we also have a term with an x squared. So all quadratic formulas can be written into this form. I've reviewed a lot with a's and b's and c's. We can factor quadratic equations. We can solve quadratic equations by factoring and by using the square roots. Factoring lets us split it up into two binomials. Square root is one way of undoing squares. And then last week we talked a lot about how when we solve quadratic equations, we can have both real and complex solutions, right? Imaginary numbers, real numbers, depending on if we get a negative underneath the square root or not. I'm building on that. So factoring is okay. It works if we can factor. Square rooting is okay if we can square root and there's no other term. But they don't necessarily allow us to solve every quadratic. The method of completing the square, which we're going to learn next, is a way to solve any quadratic formula. It's a little bit complicated, but it kind of uses factoring and it kind of uses the square root method all at the same time. So here's the steps. You want to take your quadratic equation, rearrange it so that the constants are on one side and the variable terms are on the other. Then we're going to look at adding this whole mess of stuff here, this b divided by 2 squared. We add a part to both sides, and we force our polynomial to become factorable. Again, this will make sense, so we do an example here. Finally, once we make it factorable, then we factor it, and then we solve the resulting equation. So let's use the method of completing the square and solve this one out. All right, we've got 2x squared minus 6x plus 11. It's equal to 35, and I want to figure out, well, what values of x make it equal to 35. So step 1, rewrite the whole thing. I'm going to subtract 11 from both sides, and that's going to move the constants over on the right side and leave both x terms over here. So now we've got 2x squared minus 6x is going to equal 46. Whoops, sorry, if I subtract 35 minus 11 is 24. Okay. I'm also, because I want to make things a little nicer for myself, I'm going to divide both sides by 2 because I have common factors, right? I can divide both sides by 2 and make it a little bit simpler. When you want to use completing the square, it's helpful to get your leading coefficient, what's in front of the x squared, just down to 1, because then it just makes it easier to factor overall. So now we got x squared minus 3x equals 12. All right, here's the interesting part. I'm going to force my parabola, force my equation here on the left side to be able to factor, and to be able to factor in a way where I can make it a square, a perfect square trinomial. So here's where we look at what b is. There's my value for b, the coefficient. And b is negative 3. And follow along with this, but I'm going to take half of b and square it. And if I do that, that's negative 3 over 2, but squared becomes 9/4. and I'm going to add 9/4 to both sides. I added to both sides because then it keeps my equation the same. But now let's look at what we have on the left side here. So now I've got x squared minus 3x plus 9/4. And that's equal to, if I make 9/4, that's the same as 2 1/4. So I'm going to change that to 14 1/4, or 14.25. Now let's look at what I have on the left side here. This can all be factored. Because I added half of b squared, it factors down into, let's see, x minus 3/2 times another x minus 3/2. If you don't believe me, this is where you can check it out, but multiply it back together. X times x gives me the x squared. I have x times negative 3/2, but I have another x times negative 3/2. So negative 3/2 times, or negative 3/2 minus negative 3/2 is going to give you negative 3 for the middle term. And if I multiply negative 3/2 times negative 3/2, I get my positive 9/4. So if you multiply, I get right back to this. But even more interesting is these are the exact same binomial. So I can rewrite it as x minus 3/2 squared, because there's two of them. That's what we mean by completing the square. We added this portion here, 9/4, which allows me to complete it as a square, perfect square trinomial, and factor really nicely. Let me write back. We still have the other side of the equation, so it's all still equal to 14.25. Now let's pause for a quick second. We took our original quadratic equation, rearranged it, added a specific thing, this whole b divided by 2 squared, added that to both sides, which allowed us to factor it nicely. This is now an equation we can solve, right? We did the factoring part. Now it's set up where we can solve it. We have something squared. And this is what we were doing last week. We can use the square roots, the fact that square roots are opposite of squaring, to solve this out. All right. So I want to solve this for x. I have everything in parentheses squared, so I'm going to square root both sides. And we see that x minus 3/2 has to equal then plus or minus the square root of 14.25. And now let's add 3/2 to both sides, and that'll give me x. Minus 3/2 plus 3/2, so x equals, and I got to add 3/2 to the right side as well. X equals 3/2 both plus the square root of 14.25. That's one of my solutions. And then minus. That's my other solution. That's the plus and minus thing. There's my two solutions. These are an exact form. If you wanted to find an approximation, you could take the square root of 14.25, round it to the nearest tenth, and then take 1.5 and add it, and then 1.5 and subtract it, and that would give you your two numbers. But there you go. We just solved for the two values that we could put in for x to make this equation work out. There's my solutions. That's the method of completing the square. Again, it combines our ability to factor, so we factored this right here into a perfect square or binomial squared. So we use factoring method right here, and then we used the square roots to solve it right here. All the stuff that we kind of learned the last couple weeks. Okay, well, with the method of completing the square, it's a pretty hefty procedure, right? It's not simple. It takes some work and some algebra. So what mathematicians said then is, okay, if we can make every quadratic equation like this, we can generically do the method of completing the square and shake all that out and turn it into this. This is what we call the quadratic formula. Whoops, totally spelled it wrong. For all of you watching the video, it is not quadratic, it is quadratic. So, but I have no eraser, so I can't fix it. The quadratic formula right here. Quadratic formula. And what it does is it lets me solve for x. Notice it says your x value, your solutions are going to equal all of this stuff. It's still got the same a's, b's, and c's, but we put them in the right places, and it's a formula that lets us find both solutions. I really want you to know this because we're going to break down parts of this. There's parts of it that we'll be using to better understand how parabolas work and how quadratic equations work. Let's do an example. Let's use the quadratic formula. Solve the following quadratic equation. And not by using the square root of both sides. We're going to solve this using the quadratic formula. So first thing I need to do, I need to rearrange it to get it equal to 0, right? So I'm going to add 30 to both sides. Add 30. We've got 4x squared minus 3x plus 40 equals 0. That's our first step. This quadratic formula only works if you get it equal to 0. Now, I got to know my a's, b's, and c's, so let's find them out. A is 4, b is -3, and c is 40. I'm going to put those numbers in for b's, a's, c's, a's, and that be all in the right spot. And we get my x values. If I want to solve this, x equals -b, but b is already negative, so it becomes -3, which later you'll see becomes a positive, plus or minus the square root of b squared -3 minus 4 times whatever a is, which is 4, times whatever c is, which is 40. All divided by 2 times a. And a was also 4. Okay, I just substituted all the values in the right spots according to what our formula is. And now we get to simplify it down. Let me get black here. Okay, the -3 becomes +3 plus or minus. I'm going to divide on the bottom by 8. 2 times 4 is 8. And I like to calculate what is all this stuff under the square root. Well, -3 squared is going to be 9. That's easy to do. I'm going to subtract 4 times 4 times 40. What do we get? I pull my calculator out. 4 times 4 times 40 is 640. Now, a couple of things. It's really easy for people to mistakenly miss the -b, so be careful. If your b value is already negative, then it should become a positive value in the formula. If it's a positive value of your b, then it becomes negative in the formula. The other thing students mess up a lot on is this whole stuff in between. Keep your subtraction clearly, because a lot of times if there's a negative value in here at all, then it turns into an addition. I see people mess up on the signs all the time when they're trying to calculate all that stuff under the square root. Now if I take 9 minus 640, that gives me one more step, and we get x equals 3 plus or minus the square root of -631. All divided by 8. All right, a couple things we're going to notice. We have a negative number under the square root. I'm probably going to have to deal with some imaginary numbers at some point here. And then we got 2 solutions, plus or negative. Let's work this out just a little bit more and see if we can simplify. So 631, I'm going to look to see if any perfect square numbers go into it, like 4 or 9 or 16, 45 or 41. Sorry, 49. I can't find any perfect square numbers that are factors. So I think 631, the square root of that, is as simple as it gets. So our next step is to take the negative, though, and rewrite it as an imaginary number. So x equals 3 plus or minus I times the square root of 631 divided by 8. There's my exact solution. It's not very pretty, but it would be really hard to get this using square roots or factoring. So the quadratic formula at least gives you a method of getting to your exact solutions right here. And we can see that because we have i's, we have our exact complex solutions. These are not real number solutions. But there you go. That's how we use the quadratic formula. Substitute everything in, find a, b, and c after you get it equal to 0. Substitute it in, simplify things out step by step as far as you can. So the last example, since we had complex solutions, it kind of brings up talking about when do we have real number solutions or not real number solutions. And there's 3 different cases you're going to come up with as you are solving quadratic equations. One of them is you'll get 2 real solutions, 2 real numbers. You can also get a case where there's only 1 real solution. And there's also the case of getting 2 complex solutions. As you practice problems this week, as you look through examples, you'll see situations of both. We just did one. We actually solved one and got 2 real solutions, and we solved another one and got 2 complex solutions. So how do you know which case you're going to have? It's all dependent on what you have underneath the square root right here. So we're going to focus in on just a part of the quadratic formula that we call the discriminant. It helps you discriminate. It sounds like a bad word. It helps you discriminate between what type of quadratic equation, what type of solutions are we going to get. Here's what you got. If this value under the square root, if you calculate all that b squared minus 4ac stuff and it's positive, it's greater than 0, you get 2 real number solutions. If you calculate the b squared minus 4ac and it is exactly 0, you're going to get the square root of 0, which is equal to 0, and then you're only going to get 1 solution. That whole plus or minus part is just 0. But if you get b squared minus 4ac and it's a negative numbers under the square root means you have complex numbers with i's, means you have 2 complex solutions. Okay. Let's switch gears. We can now solve any quadratic equation. We have the quadratic formula, we have completing the square, we have factoring, we have taking square roots of both sides. We have all these algebraic tools now to solve quadratic equations. Let's get a nice graphical view of what are we doing when we graph quadratic equations, when we look for x-intercepts, y-intercepts. How does all the algebra work with all of our graphical forms? So here we go. When we graph quadratic equations, remember things like y equals ax squared plus bx plus c. When we graph them, there's some certain things we're going to look for that are characteristic of quadratic equations. We're going to look for x-intercepts. Right there on this parabola, we have 2 of them. Look like a little u, right? So it's going to cross the x-axis twice. Looks like one x-intercept is at negative 6.30, and the other one is at positive 0.30. So we have to look for our x-intercepts, right? And unlike lines, parabolas, which we call this thing, parabolas have 2 x-intercepts often. Sometimes only 1, sometimes only none. So we got to look for x-intercepts, we look for y-intercepts. We like to know where it crosses the y-axis, right? So right here, I have a y-intercept at negative 1. It's at that point right there. And then we also like to know or be able to find this key point right here. It's either the very minimum, which in this case it's where it goes down and stops and comes back up, or it's the very maximum. Sometimes parabolas can look like a mountain. It starts down, goes up, and then goes back down again. But we call that the vertex. The coordinates of that point here are going to be 1, 2, 3, -3. And then we go down -5.5 roughly. And that's what we call the vertex. So you need to be able to know how to find each of these points, recognize them on a graph, and be able to label and say, okay, the vertex is this point, there's my x-intercept, there's my y-intercept. Those are key points to find. Recognize them on a graph, but then we'll be able to find them exactly using our algebra as well too. The Desmos calculator, as we get into solving quadratics, as we get into looking at parabolas and seeing this connection between equation and graph, is going to be really helpful too. So I want to show you some things on the Desmos calculator. Okay, here we are. We are signed in. I've got y equals ax squared plus bx plus c. You'll recognize that is the standard form of a quadratic equation. There's a nice little parabola here, right? Looks like a little u. And we're going to see what happens when we play around with these values for a, b, and c. How does that affect the way our parabola works? Well, a is sort of like the slope. It's going to affect how much our parabola increases. Notice that the bigger a gets, it grows really fast. It increases, it's going to get steeper. It also makes it look skinnier, but that just means it's growing faster. However, watch what happens when a is negative. Oh, it decreases now. It's a decreasing parabola going negatively. So a makes my parabola open up or open down based on if it's a positive value. Let's keep it right at 1 for now. Let's watch what b does. B is kind of funny, but it just makes it translate right or left a little bit, up or down a little bit, makes it move around. And then finally, we have our value for c. C simply translate it up and down. One curious thing is watch what happens to this value in the y-intercept right here. How does it compare with our value for c? Right here, the y-intercept is 4, and our value for c is 4. If I make my value for c -2.4, my y-intercept is -2.4. It always stays the same no matter what a is or no matter what b is. So if you have it in standard form like this, c is your y-intercept. It's going to tell you exactly where your parabola crosses the y-axis. So there you go. Have fun playing around with this. Again, parabolas in standard form. If you log into your Desmos account, click on these triple lines, you can open up parabolas in standard form, the same graph if you want to play around with it. And later on, we're going to talk about vertex form for just a little bit. You can play around with vertex form as well and see how changing h and k gives us vertex form. Right or left, up or down, same value for a. It'll help you understand that form as well. But there you go. You have a couple tools, a couple different graphs you can play around with to understand how the equation and the parabola relate. Use this to check your work as you're doing all your algebra later on. All right, so we talked about, we have all these parts of the parabola, right? We have the y-intercept, we have the x-intercepts, we have the vertex. We can recognize them off a graph, we can approximate them off a graph, but sometimes we still want to we just want to hard crunch our way through some algebra and find these things as well. So the y-intercept, if you remember, we put 0 in for x and solve for y. It's pretty straightforward. That'll get you the y-intercept of any quadratic equation, any function, for example. If I want to find the x-intercepts of a parabola algebraically, I'm going to set the equation to 0 and then use the quadratic formula, or I solve it. I want to solve for what values of x make it equal to 0. Good thing we know how to do that now, right? Finally, the vertex. The vertex is a special part of the quadratic formula, but it helps us kind of find the very center vertex of the parabola, and we're going to play around with that in an example here. But we need this formula. Whoops, it's not b squared. Scratch that. To find the vertex, we need to use the formula -b/2a. It's part of the quadratic formula. And we're going to use that to find the x value. So let's go over some examples here. We're going to do that. I've got this equation right here. Y equals 5x squared minus 10x minus 18. It's a parabola. I can graph it. Let's find the x and the y intercepts and the vertex. Crunch this thing out. Sort of summarize all that we know with quadratic equations. First thing, do the y-intercept. This one's the easiest. We already know that in standard form like this, as long as I have everything on one side and just y on the other, the y-intercept is just your value for c. So I know that if I was to graph this, it's going to cross the y-axis at negative 18. Boom, that's done. All right, check off that. Let's do the x-intercepts now. Let's do that in blue. So for the x-intercepts, if you think about it, those are the x values when y equals 0, right? Saying what values of x make it go to 0. So I need to solve this equation for when the x values, what x values will make my y value go to 0. Well, this looks familiar now, right? This is just need to solve this for x. I need to know what a is 5, b is negative 10, c is negative 18, and I'm going to solve it using the quadratic formula. I could use completing the square if I want to, but I don't like that, at least not with this 5 in front of the x squared. So I'm going to use the quadratic formula. So my x values that I'm solving this are negative b. Since b is already negative, I'm going to put in positive 10, plus or minus the square root of b squared minus 4 times a, which is 5, times c, which is negative 18, all divided by 2 times a, and a is 5. All right, I'm going to simplify this down quickly, and we'll go through it. I'm going to do what's under the square root first. So I got 10 plus or minus. Negative 10 squared is 100, but then if I do 4 times 5 times 18, 4 times 5 times 18, that's 360. But notice I got a negative and a negative, so it's going to turn into 100 plus 360, which is just going to be 460, all divided by 10. Thank goodness I know how to simplify square roots. So 460, I know 4 is a factor, so I'm going to rewrite that now as x equals 10 plus or minus 2 times the square root of 115. So I simplified that radical. Makes it a little bit easier to work with. And then I can divide some things out here as well too. 10 divided by 10 equals 1. So I know I've the same as 1 plus or minus 2 over 10 is 1/5. So it's the square root of 115 divided by 5. There's my two solutions, my x-intercepts. And let's go ahead and round it. Let's find the approximate values. So the square root of 115, if I do that, that's about 10.7 divided by 5 is 2.14. So one solution is 1 plus 2.14. The other solution is 1 minus 2.14 if I approximate it. And those are going to be 3.14 or, let's see, 1 minus 2.14, negative 1.14. I went through that quickly. We can pause it, feel free to rewind it. But what we did is, again, we put 0 in for y, used the quadratic formula to solve for x, and these are the two x values that when I put them in, they'll make my value go to 0. They're my x-intercepts. That's where they cross the x-axis at. Okay, so we got my y-intercepts. I got my two x-intercepts now. Let's find the vertex. So the vertex formula is this whole one right here. X equals negative b over 2a. Now notice that's familiar because that's this whole part of the quadratic formula, right? Negative b over 2a. we're using this part of the quadratic and ignoring the plus minus part. And so it's going to be the x value of my vertex is negative b, which is positive 10, over 2 times a, and a is 5. So it looks like I get a nice value there. That's just equal to 1. And that's telling me that the x value of my vertex is at 1. It's a nice value. So to find the y value of my vertex, I'm going to substitute 1 in, and we get 5 times 1 squared. I'm putting 1 in for all the x values into the equation, minus 10 times 1, minus 18, and that's going to equal the y value of the vertex. 5 times 1 squared, that's 5, minus 10, whoops, this should be a minus 18, minus 18, and we get negative 23, right? So my vertex is at this point. When x is 1, I have a y value of negative 23. So jot all those points down right here. Let's just double check now. So we know the y-intercept is at negative 18. We know my x-intercepts, one is at 3.14 approximately, and the other is at negative 1.14 approximately. And my vertex is going to be at the point 1, negative 23. Now I want to check my work. We just did a lot of algebra there, right? Let's take a look at our Desmos calculator, graph this thing, and see if our points actually do line up with what we have here. Okay, here I am at our Desmos calculator. I'm going to put y equals 5x squared minus 10x minus 18. Let's start by first finding the y-intercept. There it is. It crosses the y-axis at negative 18. Feeling good about that. Let's find my x-intercepts. There's a 1 at negative 1.14. They rounded it a little better than us, but I'm feeling pretty good. It's a good check. And there's the other one at positive 3.14. So my two x-intercepts we found using the quadratic formula. And finally my vertex, right down here, this little minimum point, right? We found when x is 1 is the x value of the vertex. And we put 1 into the equation and got negative 23 to get the y value. So we can find all these 4 points algebraically and substitute them in to see how they actually are parts of our parabola. Great work. Hopefully you followed along with all that. That's a lot of algebra there. Okay, so what do we got? We got parts of our parabola. We have lots of ways to solve it out. We used the negative b's and the quadratic formula to find different things. The last little bit I want to talk about is different forms of a quadratic based on what we know or based on what we have. So again, I'm going to use this last example. We just graphed this. We just did a lot of work with this parabola. And that's in what we call standard form. Right? So far, we've predominantly been working with quadratic equations in standard form. We can write any quadratic equation in standard form. But we have some other forms which are kind of helpful as well too. We have what's called root form, which is helpful if you know what the roots are. And a root is just a fancy way of saying what are your x-intercepts. So as we deal with polynomials, you'll see roots often. Same thing. When they talk about roots, it's x-intercepts. X-intercepts are roots. So if I wanted to take this equation, we already know what the x-intercepts are. We approximated them. And we could write it in this form. P and Q are just your x-intercepts. A is the same value of A as above. So in here, we could rewrite it as y equals A, which is 5, times, we have one root at negative 1.14, right, when we rounded it. So let's say x minus negative 1.14. That was one of our x-intercepts we found. It's better, you want to put exact value in predominantly, but I didn't write that down, so I'm stuck with just using our approximate value that we found. That's one root. The other root was x minus, we had positive 3.14. If I go into my Desmos calculator and graph this, it's going to look really, really close. It's going to be off maybe just by a tiny bit because these are approximated values right there. but that's root form. If you find the x-intercept, you can write your quadratic equation that way. We're going to be using this idea in the next couple weeks as we get into higher order polynomials as well. Finally, with quadratics, we know the roots, but sometimes we also like working with vertexes. So we have what's called vertex form. We calculated the vertex was x value of 1 and a y value of negative 23. We can write a whole parabola based on those values. This value h is just the x value of the vertex, which is 1. And the value k is the y value of the vertex, which we had negative 23. And guess what? A is just still the same. So if I wanted to take this equation and rewrite it in vertex form, I would write y is equal to 5, still the same value of a, times x minus 1, because that was the x value of my vertex, squared, minus negative 23. That was the y value of my vertex. Now since 1 and 23, this was an exact value of my vertex right here, so if I graph this equation right here, my Decimalist calculator, it will look exactly like that equation. It's the exact same equation, just a slightly different form. So there you go. You got 3 different ways: standard form, root form, and vertex form of writing the same quadratic equation. It just depends on what you're given, what you want to express, or what way is easier when you're trying to solve and work with word problems and quadratic equations. Okay, all that stuff there, we are done. Whew, hopefully you follow along with that. But again, we took a quadratic equation. We did a little bit with completing the square to solve it. We looked at the quadratic formula, how to use the quadratic formula, how to solve with the quadratic formula, and then we were able to solve and work with a wide variety of parabolas.